Hi everyone, this is Mrs. Jackson. This is Chapter 4, Section 1, Part 3. In this video, we're going to talk about how to find the quotient of rational expressions. As you know, the quotient means division, and we are going to find that quotient much the same way we find the quotient of fractions. And we do that by taking that first fraction. So I'll say the first fraction, but remember, that first fraction is the dividend, the thing that's being divided. And we are going to multiply that fraction by the reciprocal of the second fraction. And that second fraction is called the divisor. So I'll put divisor in here. And then in blue, I'll say the second fraction. And of course, just like multiplication, we're going to simplify the result. Okay, so first we're going to start with some rational numbers. I've got 96 fifths divided by 18 sixtieths. So I'm going to start with that dividend. You know what? It probably makes sense to label it. Let's label it. That's the dividend. That's the divisor. So I'm going to start with that dividend, and I'm going to keep it the same, but I might as well start simplifying it while I go. For 96, I think about 8 times 12. And you can break that down even more if you want to. And I'll leave the fifth alone. And then we're going to turn this division into multiplication. And then I'm going to have 60 over 18. 60, I think 6 times 10. 18, I don't know, 6 times 3. And so I multiply the numerators all together and multiply the denominators all together. So they all kind of line up here. 8 times 12 times 6 times 10. And on the denominator, I have 5 times 6 times 3. And so we can start to simplify. I can see right away here that my 6 is reduced to 1. I also have 10 over 5, so I can rewrite that 10 over here as 10 divided by 5 would give me a 2 up here. And I also see that 12 divided by 3 is going to reduce to 4 up on the top. So in the end, everything pretty much reduced out in the denominator. So I have 8 times 4 times 2 is 32 times 2, or 64 in the end. Okay, I wanted to do a second example of just pure numbers. If I have 64 thirds divided by a whole number like 12, you're going to follow the same process. So we have 64, I think 8 times 8 over 3, and I'm going to turn that division into multiplication, and the 12 I'm going to turn into 1 over 12. So in the numerator, I have 8 times 8 times 1, and in the denominator, I have 3. I'm going to change that 12 to 4 times 3. And I can see that 8 divided by 4, I'm going to end up having a 2 up here. And it looks like that's all we can do. So this will reduce to an equivalent rational number of 16 ninths. Quick discussion of some of the common student misconceptions. Forgetting to take the reciprocal and changing that division to multiplication. So I'll just come up with an example. Say 1/2 divided by 3/4. That does not equal 1/2 times 3/4. So you got to make sure that dividend, we do take the reciprocal. Obviously, 1/2 divided by 3/4, I think that will simplify to 2/3, and this is 3/8, so these are clearly not equal. Another common misconception is confusion when the dividend and the divisor are written horizontally. For example, 1/2 divided by 3/4, so written horizontally like that. I'm sorry, vertically like that. That is the dividend, and this is the divisor. So it's just a slightly different representation. Okay, so more importantly, how do we apply these concepts to finding the quotient of rational expressions? In my first expression, I have 1 over x squared plus 9x. That's being divided by a rational expression 6 minus x over 3x squared minus 18x. So we kind of take this one step at a time. I'm going to start out with simplifying this first one. I can see in the denominator an x can be factored out. So I'll have x plus 9 here. And I'm going to go ahead and keep division for a moment until we can simplify this out. The numerator, I have 6 minus x. And in this denominator, I can factor out a 3x. And that would leave me x minus 6 left. Now let's go ahead and change our division into multiplication. I'm going to just point that out here so that people can see it. And then I'm going to take the reciprocal of the divisor. So the 3x times x minus 6 is now in the numerator, and the 6 minus x is now in the denominator. And now I'm going to get everything together in the numerator, kind of written out as factors. So I have 1 up top times 3x times x minus 6. And in the denominator, I have an x. I have an x plus 9 and a 6 minus x. Now what can we simplify here? I can definitely see that we have an x that can reduce to 1, and be on the lookout for this type of thing. X minus 6 and 6 minus x, they are opposites of each other. So when I reduce that, I'll have a -1, and that looks like all we can do here. So what we have left is a -3 in the numerator, and in the denominator we have an x plus 9. Now, what is the valid domain? We have to go back and look at what would create zeros once we're in the multiplication format. So that's the row we want to be looking at. So we can see that x absolutely cannot equal 0. That would cause a 0 in the denominator. By the way, I should point out this here too, either one of those rows. We can see that x cannot equal -9, and x cannot equal +6. And I think it's worth pointing out here that a common student misconception would look at what would create zeros here with this expression, 3x squared minus 18x. That's actually really in the numerator, so don't fall for that. Just a caution there, because I've seen many students do that in the past. All right, for a second example, we have two expressions, 2x squared minus 12x over x plus 5, being divided by x minus 6 over x plus 5. So that first one, I'm going to go ahead and pull out a 2x in the numerator, and that would give me x minus 6 left, and I've got an x plus 5 on the denominator. Well, I guess we can probably go ahead and turn this into multiplication at this point, since I don't have any simplification to do. So I'm going to turn that division into multiplication, and now I'm going to take my reciprocal. So the x plus 5 goes on the numerator, the x minus 6 is in the denominator, and now we can start doing our multiplication all across. So in the numerator, I have 2x times x minus 6 times x plus 5 And in the denominator, I have x plus 5 times x minus 6. And we could see that our x plus 5 reduced to 1, our x minus 6 reduced to 1. And this big complicated quotient of rational expressions reduces all the way down to 2x. So what rows are we looking at to determine our valid domain, either here or here? So we can see that we would have to exclude x equals -5, and we have to exclude x equals +6. All right, so in this video, we looked at rational numbers and finding the quotient of those, talked about some misconceptions, then we applied the same concept to finding the quotient of rational expressions. Hope this video helps. Thanks for listening.